This is a Math 2 lesson summary video for the lesson titled Slaker's Simulation. This is a solidify understanding task. The purpose of this lesson is for students to decide if a particular result from a model is likely using a simulation. I know a student who forgot about an upcoming history test and did not study at all. To protect his identity, I'll just call him Slaker. When I reminded Slaker that we just had a test in class, he said that he wasn't worried because the test was 10 true-false questions. Slaker said that he would totally guess on every question, and since he's always lucky, he thinks he'll get at least 8 out of 10. I'm skeptical, but Slaker said, hey, sometimes you flip a coin and it seems like you just keep getting heads. You may only have a 50-50 chance of getting heads, but you still might get heads several times in a row. I think this is just the same thing. I could get lucky. I thought about it for a minute and said, Slaker, I think you're onto something. I'm not sure that you will get 80% on the test, but I agree that the situation is just like flipping a coin. It's either one way or the other, and they're both equally likely if you're just guessing. My idea is to use a coin flip to simulate a true-false test situation. We can try it many times and see how often we get 8 out of 10 questions right. I'm going to say that if the coin lands on heads, then you guessed the problem correctly. If it lands on tails, then you got it wrong. This is called a simulation. Flipping the coin imitates guessing true or false on the question on the quiz. Doing this 10 times imitates answering all 10 questions. This way, we can see different outcomes for him taking the quiz and seeing what kind of grade he would get. Let's run this simulation. With the first group of 10 pennies, only 3 of them are heads. That means that he only answered 30% of the questions correctly. With the second trial, 7 of the pennies were heads, meaning that 70% of the questions were answered correctly. On the third trial, 5 of the pennies are heads. On the fourth, only 2 pennies were heads. And on the fifth, 5 were heads. After 5 runs of the simulation, none represented Slaker getting 80% correct. Slaker didn't think this was likely and wanted to run more simulations. With technology, Slaker ran 50 simulations. After running 50 simulations, he collected the results and made a histogram. This time, there were 3 out of the 50 runs that scored 80% or higher. That's a 6% chance. He then ran 200 runs and found that 6 of those 200 runs scored 80% or higher. That's a 3% chance. It looks like Slaker was incorrect. If you randomly guess on a true or false test, it would be difficult to get an 80% or higher. As we look at these histograms, notice the histograms are symmetric and have a center at 5. As you continue to run more trials of a simulation, the center will move towards the theoretical probability. In this case, since the theoretical probability of getting heads is 1/2, the center of the histogram will be at 5 because 1/2 of the 10 coins that you are flipping is 5. In this video, we've been calculating experimental probability. When we ran a simulation of flipping 10 coins 5 times, we found that none of those trials produced 8 or more heads. This gave us an experimental probability equal to 0. When we ran the simulation 50 times, we found that 3 of those 50 trials produced 8 or more heads, giving us an experimental probability of 0.06. When we ran the simulation 200 times, we found that 6 of those trials produced 8 or more heads, giving us an experimental probability of 0.03. With experimental probability, the more trials you run, the closer you will get to the theoretical probability. The theoretical probability of an event is found by dividing the number of favorable outcomes by the number of possible outcomes. When you flip a coin, there are only 2 possible outcomes. If you're looking for the probability that you will flip heads, then there is 1 favorable outcome. That means the theoretical probability of flipping heads is 1/2. The probability of choosing a card out of a standard deck of cards that is a heart is 1/4. There are 13 hearts in a deck of 52 cards. 13 divided by 52 is 1/4. Alright, that's it for this video. Thank you for watching.